Right. Okay. So you should be able to see a file called type.lean. Does everybody see this? Yep, great. So I want to disregard this file for now and go to this demo file called what is a type. And actually, I added some new stuff. So let me copy this and overwrite this. Okay. So it's going, there are some orange bars, but the file is, those are for compilation, and the file is compiled quite fast because the cache of the file was already stored. And if you continuously add something and you want to save the cache, then so that the next time it builds easier, I would recommend opening a terminal. And in the terminal, you write such a thing as Lake. So Lake is the package manager. You write build, and you write proof lab 4. So what this does is, like, if you have some new files, right, and you want to compile them and save the cache of those compilations so that next time the cache loads is faster instead of building it anew, these commands help with that. So it's building the whole project proof lab 4, which includes the demo file and source files. Now, this didn't take much long because all of the files were already, I didn't add anything new. But suppose if I wrote like a 10,000 line code here, then this would take a bit of time. And then you would save, your work essentially. I put this command later on the Zulip. Any questions about this Lake build proof lab 4? Okay. Right. So let me start by some puzzles. Actually, how many of you had time to go through the source file type.lean? Did anybody have time to go through that? So since nobody's saying anything, I assume that nobody actually had time to go through that. But for future, the plan will be that whenever the source files, essentially the files in the source folder, are things that you should go through. Essentially, I'm not going to lecture on those. So you will essentially write those things, and I'm not expecting you to get everything. But usually the point of those things is like, it's a sort of tutorial. And if you don't understand something, then you should write it down somewhere or have it on your mind so that we can discuss it during the lectures. So the lectures are essentially about your questions. You should take more center stage than me talking all the time. But because, like we had only one lecture and then you had to install Lint, so I can quite understand this week. But so usually what happens is, like, I'm going to lecture on the demo files rather than the source files. So here's a demo file called what is a type.lean. So here's the first puzzle. I want you to think a little bit and guess what the result of evaluating these expressions would be. So here's an expression, 2 minus 1. And once I evaluate that, what does lean, or rather this info view, would output? That's the question. So I want on my screen, Langi is on the left side, then there is Sherry in the middle, and then there is Kylie in the right. And I want to do this clockwise order. So I start with you, Langi. Maybe you tell me what the result of this would be.
Is it just 1?
Okay, let's try. So if I uncomment this, like if I delete these 2 dashes, I get a problem because Lin is telling me to provide a command, and eval is not a command. If you add a hashtag, then that becomes correct. Exactly, and that's 1. So maybe a follow-up question on this. What is the type of this one?
natural numbers.
That's right. And that you can check by command. So we actually so far only learned two commands, check and eval. Check gives you the type and eval gives you the result of evaluating that expression. You're right. So Sherry, it's your turn now. What do you think of this one?
Is it a negative one?
Let's see. Who thinks this is negative one? Who else thinks this is negative one? Okay. Okay, all of you. Let's see. Ooh, 0. How do we explain this?
Is it because like it assumes 1 to be a natural number, so it only gives you a
Right.
natural number?
Okay. Or rather, the term is parses 1 as natural number. Right. Wait. I'm having problem with my Windows. Okay. Right. Exactly. So it parses 1 as a natural number, not an integer. And this means, and therefore, this operation is subtraction of natural numbers. Now, the way that subtraction of natural numbers is defined, this subtraction, it's a function. So, which takes two natural numbers and outputs again a natural number.
Well,
Therefore,
what happened?
sorry, go on.
What would happen if you didn't put the number eval, but you put just eval? Like, would it do anything?
You mean like just eval without anything?
No, like you don't do like the hashtag.
No. I already get an error here. It thinks like, so if I put it above everything else, let's say, it says expected a command. And this is just like a string of letters, essentially.
Okay.
Usually commands in Lean start with hashtag. And you see, like when you write this, Lean doesn't understand what this is, and it doesn't make it blue, or like this is highlighted, because it understands that's a command, while this one is not, so it doesn't even color it as blue. Or yeah.
Okay.
Does that make sense?
Yes, thank you.
Right. So because the output of 1 minus 2 should be a natural number, it cannot be negative 1. And actually, there's a system behind this. And the system is, if the second number is bigger than the first number, the result always will be 0. So we will see this later, why this thing should be true. But for now, I mean, we can just skip why, maybe the reason behind it. But later we will see the reason behind it as well. The result of m minus n for n bigger than n is always 0 for natural numbers.
If I wanted to output a negative number, would I have to cast it?
Yes,
An
exactly.
integer?
Absolutely, that's the right term. So which one, 1 or 2 do you want to cast?
Does it make a difference?
I don't think so. I think in either case, like, so you see, now you get negative 1. As you said exactly, first we cast 1 to be an integer. And there is this casting behind the scene. What's going on? Lin, I think, is using this thing, nat to int or something, maybe. No, there's no such thing. Maybe int of nat. Oh, there's such a thing called int of nat, right? Oh no. I'm sure there is such a thing. I just don't remember the name right now, but anyway, we'll see this kind of things later. Anyway, so there is a function that actually like takes a natural number and treats it as an integer, and that is what's going on here. So this is called casting. Any question about this? Okay, actually, just to try that, both options give the same answer, just to see that. So this is also -1. But is there a difference? Is there a meaningful difference between the two expressions? Or the way that Lin parses them? So the way that Lin parses expressions usually is like, whenever you have an expression, like let's say any expression at all, like so that might have like A, B, C in it, plus some operations here. Then what Lin does is like makes a syntax tree out of this, and then it has to figure out the type of each term in here and the type of operation, meaning that what sort of operation is this? So what's going on in here is that, okay, so you have one expression, the type of which we give explicitly. So not so much inference is going on there. So Lin knows that the first one is an integer. The second one, it really doesn't know yet. So what Lin does behind the scene, it puts a question mark here. Okay. So I'm now just trying to tell you what's going on inside the mind of Lin, right? You will not see these things. These are called elaborations, and they happen behind the scene. But okay, so and now it wants to understand the type of this minus, right? And so it knows that the first one is an integer. So the type of minus should be that it's a subtraction of integers that it can infer, because subtraction is a sort of like homogeneous kind of operation, which means like two arguments of the subtraction should have the same type. It cannot be that one is integer and the other one is a natural number. Since the first one is an integer, the second one must also be an integer, so it also infers that this is an integer, right? And therefore, that's why we get -1. So that was the process of parsing. So let's see what happens here. Here, first it puts a question mark, doesn't know it, right? But now knows that the second one is an integer. So it comes back and infers that the first one must have been an integer. Does that make sense?
Yes, but what would happen if we were to cast 1 into like a natural number or a rational number or something different than an integer?
Let's do that. So we can do another one. So let's choose 1 to be a rational number and 2. So the result, it's going to be -1, and it says the expected type is Q. So in fact, if you check this, it has to give us rational number Q. Yep.
But what if like after we casted 1 to a rational number?
I see. So you mean like something like that?
Yes.
Oh, I'm curious actually. Okay. What is your guess? What should be the type of this?
Maybe it's going to be casted as a cube because
I think it'll be an integer, right?
yes, because it's gonna. I feel like if they cast it, they should follow the one that has more restrictions.
Right. So what it does is like, so let's see, it is a rational number, right? And then there's this funny upper arrow symbol going up. So you can actually see that there is that upper arrow is called int cast q, right? That means this int cast q, let me write it down actually, that's an interesting thing. I was actually searching for this. Okay, so this is like int.cast is a function. We get to functions later, so I don't want to say much about this now. But essentially, it's a function that provides all casting possibilities for integers. So you see, like you can cast an integer, you can consider an integer as a rational number. Integer as a rational number. But also, it's a real number, but also as a complex number, and so on and so forth, right? So there are multiple castings that can happen for a number like -2. And we can see this by saying -2 is in Q, so that works. And we can cast -2 to be R, and we can cast it to be in complex numbers. Ooh, this doesn't work. That's interesting. So apparently there's no casting. Okay, so there is a casting, but it's more complicated than I thought. It's the notation problem. So for now, let's ignore this. So maybe. So, okay, we have at least 2 castings here, right? And if I do like the casting for Q, it's int cast Q, right? Okay, I'm getting a problem there. Or maybe I need some add here. Okay. So, okay, we don't need to understand this right now, but later we come back to this kind of things. But what's happening here is essentially this function is a function that, you know, that's going on, that's what's going on here. So what I have written here essentially is applying this function to -2 as an integer. So I'm expecting that I would have, so here's a proof of that essentially. So I'm saying if I cast -2 as an integer, that is going to be equal to the result of applying the function here to -2 as an integer. And now let's give a proof of this. So we haven't started actually talking about proofs yet. So this is something that is not in the scope of this week, but just, you know, just for fun. So reflexivity should do this. Ooh, it doesn't. Okay, I wonder why. It's because of this. Anyway, so I don't know what's going on here, but what is expected to have type int cast? What if this? No. Okay. Anyway, so let's ignore this for a moment. We'll figure this out later when we get to these topics. But essentially, like, so this is essentially what's going on here. And if I write R here, maybe that would also exist. And this is, you know, behind what's going on here. So let's come back to your question, Sherry. You asked Do you remember what your question was actually?
I think it was like, is there like a hierarchy when it comes to casting? Like if
Absolutely.
since
So maybe
integer is more restrictive, does it get cast, like an integer will always get cast to a rational number if we're like choosing between two. It's always going to choose the one that's, I guess, more has a broader scope of numbers.
that's right. So this is the direction of casting, right? If I have a natural number, then I can consider it as an integer, like 2 is also an integer, and a rational number, and a real number, and also a complex number. There are many number systems. But usually these are one directional. Like there is no way to cast an integer as a rational, as a natural number, right? So if I have -2 here, I cannot consider -2 as a natural number because naturals don't have negative. Because this is, going from left to right, what happened here, we were asking why is this considered as element of Q as a term of rational numbers. The reason is because Lin knows about this directionality here, right? So it takes 2 as an integer, and the first one is a rational number. So in which place can we unify them? It definitely cannot be in integers, because the first one is a rational number. The only place that 1 and 2 can be unified where by casting 1 and 2 can be unified, i.e. considered as elements of the same type, is Q. Therefore, the subtraction operation is a subtraction of Q. Does that make sense? Great. Let's do the next puzzle. Maybe this time Kylie would like to say something about this.
I think it would be 0.
That's correct. And this 0 would be 0. I think you're muted.
Sorry. Like you're saying, like what type would 0 be?
Exactly.
An integer.
An integer. And what's the reasoning behind this?
I guess 1 and 2 are both naturals to start with. I can't remember if 0 is also considered a natural number or not. So I guess if 0 is, then I think it would be a natural number. But I don't know. Some people think it's not. So then I think it'd be an integer.
Okay. We can check this.
Yeah.
It says natural number though.
That's a hot take. Okay. I guess that makes sense since the type of the other two was.
I think it understands the type of other two as natural numbers, and then it treats the slash as division of natural numbers. So the output has to be a natural number. And what's going on here is like it divides, like if I divide 5 by 2, then the answer would be perhaps 2.
Yeah.
And what's going on is like, I want to have everybody. What's going on here is like, Lin thinks this natural number division asks how many 2's can be found inside 5. Well, at least 2, but definitely not 3. So the number will be 2 as a natural number, And what happens here is like you can write 5 as 2 times 2 plus 1. So it ignores the remainder and just returns out the quotient. So that's sort of like the natural number division. But what if we wrote, sorry, what if I wrote a value of 5? Now I consider that's a rational number. And then divided by 2. So in this case, I think it would give a half, essentially, like 2.5. But like the representation is more like this, 5 divided by 2. Does that make sense to everybody? Wait, I cannot find this, right? Okay, I want to have everybody in the picture, but also I want to have you vertically on this one. Okay, apparently it's not possible. Ah, good. Right. What about the next one? So it's Lang Yi. It's your turn again.
It's gonna be 512. I think it's a natural number.
32.
Oh, wait. Oh my yeah, 32. Yeah. Yeah.
I don't
it's
remember what you said, but it's a natural number.
Yeah,
That's all we
it's
care.
2 to the 8. It's 2 to the 8.
I mean, if you ask me, I perhaps wouldn't be able to give you the right
yeah,
answer.
it's 32. Yeah, no, I think it's a natural number.
I mean, the good thing is like we have Lean to do this for us, so we don't care. But what about the next one?
Will it be 1/32?
Let's see. Oh, an error. That's an interesting thing. Can we see what the error is? Can we read it, understand it?
Fail to synthesize instance.
So these are beyond what we have learned, but essentially what it says is like that Lean doesn't know how to exponentiate a natural number to an integer. Because that instance of like exponentiation has not been defined. But what if we do actually, what if we write, so the result, as you said, exactly has to be a fraction, a quotient number, right? So what if we consider the first one as a rational number, like 2 as a cube? Then it should give the right number. And indeed it does. It says 1/32. So what happened here was like, it didn't know how to coerce 2 to be considered as a rational number. Because if it did, then the second one has type integers and then they cannot be unified. So it's a bad casting, bad coercion, essentially.
So do all numbers on Lean, if I don't cast them, do they start out? I don't know why there's something stuck in my throat. My voice is funny right now, but do they all start out as natural numbers?
Yes, the default type would be a natural number. Not for example, like if you write check -2, that will not be a natural number. That cannot be a natural number. But like if you write check 2, then yeah, that would be a natural number.
Okay, but check -2 would just then be like, we would assume it's an integer.
That's right. Like
so
that,
when we parse, then why doesn't the 2 also just have a question mark, and then we assume that it's going to be an integer?
You mean the 2 in here?
Yes.
Well, it would be fine. So that it can do. But then the problem is like the exponentiation of an integer with an integer is not going to be an integer. And the problem is that then Lean doesn't know what this is.
I see.
Because the result is going to be a rational number, right? The problem here is like this operation, exponentiation, which is this, it's not closed for integers. Or rather, we say integers are not closed under exponentiation. Which means the output is not necessarily an integer.
I have
how
another question.
numbers are closed under exponentiation, so we don't have that problem with natural numbers. Sorry, go on. That was a question.
Oh, sorry. Yeah. I was wondering, like, so it seems like every time you have a problem with like the types not matching up or it not understanding because, -1 doesn't exist as a natural number, like it feels like the problems are generally solved by like upgrading your type, like one category, right, to like the next bigger bucket. So is there some way to ask Lean to be like, anytime you have an issue with the type, just like turn your natural numbers into integers and turn your integers into rationals, like until it works. So it just automatically does that.
That's a great question, and we will answer this next week. So one tactic to deal with numbers, there's a tactic about so tactics are sometimes used for automating tasks. Like the one that you mentioned is a task that we want to automate. And there is a tactic for casting, which automates this kind of, so we don't have to provide it by hand. And it's immensely, which we will learn.
Okay, thanks.
But that was a great question. Thanks a lot. Because exactly, because we have this sort of a structure, right? Where one is sort of like contained, like imagine a sort of like, bunch of like containers, and like each one is contained inside the other one, right? So you can push from the inner to the outer, but you cannot push from outer to inner, sort of. And because the direction is clear, I mean, if we had one arrow in here that would go like, backward, then things would be complicated sometimes. But because all of them are unidirectional, this can be automated. And that's why we have this tactic, which we will talk about later. Okay, I think the tactic, it's cast nom or something, but never mind, we talk about this later. Okay, so that was puzzle 1, and maybe now we do puzzle 2. So I want you to be lean for a moment and give me the type of the following expressions. So if I check 2023, what do I get?
Natural number?
I hope so. Yes, good. What about this funny thing? Bracket, 2023 bracket. So these are how we, so there is these kind of things are explained in the source file, so it's good to go back there if you have not seen this syntax. But this is what is called a list. So maybe actually, since we have not done our homework, maybe I should go back to, because it doesn't make sense now that I put these puzzles, but we don't know the basics. So I want to go back now to the source file and follow up from there, because really I haven't lectured about these things before. So so I would say I'm now here essentially. So we want to construct new types from the old ones. So far, basically, we have a bunch of like 4 types, right? There are number systems like natural numbers, integers, blah, blah, blah. And they are like, so 4 types that we know, but clearly that's not enough to, capture all of mathematics with these 4 types. I mean, we have things which are not numbers. We have lists, we have graphs, we have topological spaces, we have functions. So we have to have a way to sort of like expand our type theory to be able to model other mathematical objects of interest. So that's why we need a system to generate new types from old types. And hopefully once we understand this system, we can get from these basic types any type that we basically want. So everything will be constructed at the end from numbers. And, you know, this was quite understood like already in 18th century and 19th century by German mathematicians like Kronecker and Dedekind. There's this famous quote by Kronecker, which says, God created integers and the rest is essentially done, like the rest is by humans, the rest of mathematics. I mean, later Dedekind, like it was like 50 years after that, maybe he came up with a better system where he essentially said, I just need one infinite set for natural numbers, and then the rest can be given, can be constructed from that. So everything can be constructed from natural numbers, but that's like the basic type we need. And now I want to, this is the start of our journey where we understand how this is done, like how everything in mathematics can be generated from just type of natural numbers. And this will be the power of type theory, essentially. Is this something that makes sense or makes you excited about this or makes you dread? Whatever feeling you have about this, I don't know.
Professor, what are you talking about? We're always excited.
Okay, great. I mean, there are certain things in mathematics that makes me excited, but also like, you know, a bit dreadful because just the depth of it sometimes. But and I think this is also one of those exciting things that we will get to the end of. So it's not going to be dreadful, hopefully. So let's start from here. So when I write, for now, you can ignore that section. Essentially, what's going on is like whatever I write between section and an end here, it's going to be within this block and not be visible to the rest of the file. Okay, so it's like this hidden place inside the file that we can safely experiment. For example, you might, you know, choose the same variable that we are introducing here later outside the file, right? And there will be no problem with conflicts or whatever. So the main thing is here, though, I'm introducing two variables, A and B, and I'm writing AB column type. So what this, we sort of like discussed this, right? I think we discussed last lecture how we read such a thing. Maybe I should write X. Does anybody remember how we actually understood this, like semantically? What does this mean? Like we already seen a bunch of it, like so this one. How did we read this?
Two
Like
is
you're
a
saying
natural
that
number.
2 is a natural. Oh, sorry, go ahead.
I think you're both right. So 2 is a natural number. So 2 refers to this one. Is refers to the column. And natural number refers to the type. So if we repeat the same pattern up here, we usually write X colon A to mean X is an A. So A would be a type and X would be a term. So if I wrote like, I don't know, maybe I sacrifice your name, Langi, but this means like, right. So there is a type of humankind, let's say, and it has terms or members in it. So this is in the same category as like, I mean, okay, if we are free to not model humans as types, but if we have a type of human, let's say, then this would make sense in there. Or we can say Sunday is a weekend. So there's a type of it's a weekday. I mean, there's a type of weekdays, and then Sunday is an element of that. And this type has only like 7 members, right? But of course, like if you write check Sunday, Link will not output anything interesting. It says, I don't know what Sunday is, because we have not defined weekday nor Sunday yet. And also same with human. So these objects are undefined for Link, but we learn how to define these things later. So what I'm doing here when I write AB type, so maybe I should do it one by one. Let's just do A type. So if I do A type, so the meaning of this is following the same pattern would be that A is a type. But what does this mean? Let's think about it. So what does it mean that I write type in here? What does that say about type like this one?
So type is itself a type of all types.
Exactly. So this means we should have a type. And indeed we do. And this is the type of all types. So later we will see that this will lead to a contradiction if we have a type of all types. It's called a Russell paradox, or divergent with types. It's also called French mathematician Girard. So we cannot have type of all types, but this is we can you know, the reason for this will be, as we will learn later, is something has to do with size issues. Like if we were to have a type of all types, that thing would be too big to be a type. So later we will learn that this is really not type of all types, but it's type of all small types. But I mean, okay, so this is a caveat which we can discuss later, but for now, you can think of type as type of all types, okay? So it's not, it's going to be helpful, just that there's a caveat with that. So when I write—
Wait, sorry, can I ask another question?
Yeah, absolutely. Go ahead.
So I don't know if I'm misunderstanding. So you're interpreting types as like a set, more or less, and then you're saying that the problem with like the type of types is arising just due to like the size of the set, or like the countability of its size?
That's
is that—
basically that's the gist of the story. Absolutely. So
Okay.
so for now, if you're familiar with sets, then I think it's a good idea for intuition to think of types as sets for now. And for most of this course, I would say. Yeah, thanks. That was a great point. So yeah, feel free to, whenever I write a colon type, essentially to understand that A is a type or A is a set. And when I write variable that, it means that I'm not assuming A being a type. So this is my assumption, right? I don't know what A is. I'm just saying, essentially, the meaning of this is, suppose A is a type. Does that make sense? Like,
A is a type, and it could be any type.
it can be any type, right? So it's a bit like when you write let n be a natural number, you write like things like this variable. So I know that n is a natural number, but that's the extent of my information. I don't know anything else about this n. I don't know if it's odd. I don't know if it's even. I don't know if it's positive or it's zero. All I know is like this is just a variable that refers to a generic natural number. So a variable n is just generic means it doesn't have any extra property. So in your head, imagine this natural number line where you have 0, then you have 1, then you have 2, then you have 3, and so on and so forth, right? And when you write variable n in n, it's almost like you drop some, something on this line, and randomly it lands somewhere. Like from the sky, you throw some coin or whatever on this natural number line, and it drops somewhere on this line, but you don't know where it drops because there's some cloud that precludes your view. That's like this. You know it's somewhere, but you don't know where it is. Does that make sense? And when I write like variable a type, so a is a type, it can be anything, but I don't know what it is. And therefore, when later you prove something about this n, right? So for example, let's do this. We can always prove that n plus n is equal to 2 times n. This is a statement. This is an expression which has equality, which says like left-hand side is equal to right-hand side. Left-hand side has a plus operation and right-hand side has a multiplication operation. So these are two different expressions, right? And we want to prove this. And we will learn how to prove such, theorems. But so the n that I'm using here is not any specific n, it's this one. Which basically means that this statement is true for all natural numbers because I didn't make any specific choice. So therefore, you prove this theorem in its vast generality about all natural numbers. For example, if I wrote 1 plus 1 equals to 2 times 1, then you can prove this by reflexivity, right? But I doubt if you can prove this by reflexivity. Let's see. No. Because this is a stronger theorem. It's not about any specific natural number. It's about all of them at the same time. So the statement below is a generalization for all. And the proof cannot be as simple. Okay, you might have heard how you prove this kind of statements. Does anybody know? So there is this principle called induction. And that principle of induction we will learn because we need a tool to prove like certain thing is true for all natural numbers. And this, I mean, you cannot like, just check it for 1 and check it for 2 and check it for 3. That will take just infinite amount of time, right? So we need some new principles to help us to do those kind of reasoning. And this we will learn how to do with induction later. But for now, let's just ignore this. By the way, note that when I have this, so if I comment this out, I have 2 errors in my file indicated by this warnings cross sign. But if I include this, because this is an error indicated by this squiggly red line, then I get 3. So just, this counts your errors and warnings and whatever. Okay, great. I have just 4 more minutes, and I want to just maybe mention a few things about this type constructor. So the idea was like now we had a bunch of types and we want to construct new types out of the old ones. So let me say that I have 2 types. Let's suppose we have 2 types, A and B. Then there's this new type called A cross B, right? Which is really just a notation for product of A and B. So if we check prod AB or A cross B, we get a new type. right? Which is not A or B, it's just a new one. So once we introduce a type, we should also tell what are its terms, you know, what are its elements, essentially. And so maybe I do a sort of like a schematic table here or a line. So if I know, you know, A is a type and I know B is a type, then I construct this new type. And okay, now I'm curious how to construct like terms of this type. So what are, you know, what are typical terms? And here's my rule. So I'm giving you a rule. I'm saying that this is type of pairs. By that I mean, if I have a term in A and I have a term in B, then I pair them up. And this will be how I construct new terms in the type A times B. Okay. So for example, because natural number is a type, I can cross it with itself. So that gives me a new type. And now the terms of this are pairs of natural numbers. And when I check 1 and 2, indeed, I do get a term of net cross net. Does that make sense? Okay. So, and now here, like I have constructed, you know, natural number cross integers, and 2 and 1 is the term there. You can also check that 1 and -2 is going to be a term in there. Okay, great. Let me see. I have 1 more minute. So if you have a type A, then you can construct a new other type called list of A. So this is type of all lists of A, which means terms of list A are list of terms of A. Right. So for example, there's a type called list net. So this is a new type. And you specify a list essentially by just sequence of elements within these 2 brackets. So here's a list that has 3 elements, 0, 2, 5. And when I check it, you know, because 0, 2, 5, they all individually are like terms of natural numbers, right? So maybe here's a puzzle for you. What would be the type of... So can you lean for a moment and tell me what this would be? Yep. Any idea?
Integers? List of integers?
I think so. Great. Because there's casting going on, right? So this first is Lin puts that question mark. Okay, maybe it's a natural number or maybe not. I don't know yet. This one it knows is an integer. So the first one must be an integer because, you know, list takes 1 type only. It cannot be list of, you know, heterogeneous types. So it has to be list of only 1 type. And so that would be list of, great. So this is list of integers. And what about, okay, this is funny. So if I write just, this is empty list, it doesn't have anything in it. It's a list whose length is 0. It doesn't have any member in it. But it doesn't know list, what is this? You know, it's a question mark. So it doesn't know the type of it, right? because it really doesn't know what is the type of the term inside the list, because there is no term inside the list. So it can be list of anything. So that's why it's put questions mark here, right? So, but you can specify that this is list of, let's say, real numbers, if you like, by coercing. Okay. Okay. I think I explained this here, but you can also make it list of natural number. So this is funny element. It can have infinitely many types at the same time, but it really doesn't, because as we said before, every term has a unique type. So we have to specify what type it is. Otherwise, Lin will be just forever undecided. I think I want to stop this time and not go too much over time. Yeah, so the homework essentially will be, I will release it on Friday, tomorrow, maybe even later tonight, and will be about the kind of things we discussed. And hopefully next week, I will start talking about functions, and they will be the most important thing we will cover throughout the whole course. Any questions?
Yes, and do we have meeting tomorrow?
So this is something else that I have not yet talked about, which is, so there used to be a section for this course, and usually I would have a TA to run the sections. But because the course is very small and it was organized in a weird way, I'm not in there to, communicate with my TA. I'm going to run the section myself. But I think if you don't mind, I'd rather do the sections on Monday. So we have two options, actually. We have Friday and Monday. But tomorrow I'm not available. I mean, tomorrow I'm moving houses and stuff, so it's going to be quite a messy day. But I think next week Monday is a good day, but next week Friday is also a good day. On the other hand,
sorry,
yeah.
I would
Go
say
ahead.
next week Monday is technically Labor Day, so I think technically there are no
That's right,
classes
that's right.
next week on
That's right.
Monday.
Thanks for reminding me. Yes. So let's actually discuss this on Zulip, if you don't mind. I'll make a few proposals and then you tell me if it works for you or not.
Yeah.
Okay. Any other question?
This is more of like a personal question. I was just
Sure.
wondering if you have time after class, because my lean is still kind of a little goofy and I don't know what the issue is.
Your installation is a bit goofy.
Yes.
Yeah, sure. So just after the class right now, do you have time?
Yes, I do.
Okay, great. Yeah, let's do that. I'll send you a separate Zoom link.
Okay.
Kylie, do you have a question? Okay. So if there's no other question, then I'll see you next Tuesday. Same time.
Yes, thank you so much.
Okay. Have a good day.
Good
Thank
day.
you.
Bye-bye.
Have a good day, y'all. Bye.